Hi, this is Anshul, and I'm working on this application which will be. So yes, so on the screen you can actually see an application that I'm working on. Now, essentially, the idea of this application is to uh, get weather data. So essentially, what it will do is it will connect to a weather website and fetch the data, which will be stored in an SQL database. So whenever there is a new request, and if the database already has the content which is needed, so it will be fetched from the database. Or if the content is not present in the database, then the request will be sent to the web server, and the data will be fetched from there and cached into the database. So it's not really finished at this specific point. There are a lot of other things to be done, but here's kind of what I have done so far, and I will start with some of the basic files which I have created, which are kind of wrappers, object-oriented wrappers for uh, to hide really the interfaces which are in the background. So so let me start with the number interface, for example. Now here is the class which you can see. So this is how I usually start with it, which is ag lib and ag num, which is ag is for Anshul Gautam, that is me, and then I have the MSc version number. So essentially what this does is it checks if we are running in Windows, or if not, then it is going to define something else. So for example, if you are running on the Linux, for example, uh, then this specific hash define will not come into existence. Okay. And now so here you can see there is this class which I have defined, which is called as ag number, and this is actually an interface. And essentially what it does is I have these two variables defined in over here, which is a long number and a double number. So essentially you can think of it as the long number might be associated with, say for example, wind speed on a specific day, and the double number will be associated with some other metrics, such for example air pressure or something else, right, which is going to be having a decimal point. So that is going to be our double number. And then we have this buffer. Okay, and these are the private variables in this class, and then the public functions which will actually operate on all these numbers. So for example, the version API will actually get the version number. So you can see there is a version number which I have defined right over here, AG version number, right? And this will be returned whenever someone queries for the version number of this interface. And then we have this constructor, as you can see. So this is our default constructor, and it has it initializes the long number variable to 0L and double number to 0.0. Okay, and then we have these signatures. Again, these are different constructors. So for example, they usually take different inputs. Here it takes integer. Here it is going to take a long integer. Here it is going to take a double, and here it is going to be a character pointer, and here it is going to be the object itself, a reference to that specific object. And again, this is our copy constructor. So these are all different signatures of our constructor, and this is our destructor. And then the reset, which essentially resets these values. And again, I will be showing you the function implementation, and this is the string long, so it kind of it returns the long version of this number as a character pointer. And then you have the add function, subtract function, division function, multiplication function, and each of these, they take in a reference to our object, and then they return a reference to the object. Okay, and here you can see the operator. So for example, these are the operator overloads over here, and again, there are different function signatures, as you can see. So for example, this one takes an object of AG number, and then this one takes long, double. Okay, these are all the assignment operators, and then these are the addition operator. So the left hand side will be added to the right hand side. Again, this is implemented, so I will quickly walk you through that in a minute. And then you have minus, equal to, division, multiplication, and then there is this operator equal to, which checks whether two objects are equal or not, and based on that it will return true or false. Okay, and then again these are defined as const safe, so that none of these variables are modified internally by these functions. So I have defined it for not equal to, greater than, less than, greater than equal to, and less than equal to. Okay, and then there is the increment operator, and this is another version of it. Okay, and again the string one is yet to be defined, so that's why you see a green zigzag line below it. And this is the integer operator, and this simply returns the integer value, which is going to be stored in the integer that you saw here. Okay, and these are the non-member functions that you see. Again these are operator overloads. So you have the plus operator, minus operator, division and multiplication, and it takes both the left hand side as well as the right hand side. Okay, because it's a non-member function, it's not a part of the object, or it's not a part of the class. Okay, so let me take you to the definition. Okay, so I'm gonna move this a little bit, and where do we have the definition? Okay, I guess I have, it must be over here somewhere. There it is. Alright, so I'm gonna quickly walk you through all of these functions over here. So here you can see AgNum. Okay, and this is our constructor, which actually takes a reference to an integer, and it is going to initialize our variables in the class. Okay, so it initializes the long number, so it directly takes the variable and assigns it to n. But for double, it is going to typecast it to a double. Similarly, these are the different variations that you see. So for example, this one takes a long number, and since it is already a long number, it is going to be assigned to underscore long number, and then we have this double, which is assigned to the double number. Okay, and in this case, since we are passing a double number as a reference, we typecast it to an integer and assign it to underscore long number, and here it is assigning the double directly to the class variable. Okay, similarly we have the character pointer. So for this we call the function ASCII to long, which actually takes the string or the character pointer, and then converts it into a long integer. Similarly, there is ASCII to float, which converts the character to a double number. Okay, and here it is our copy constructor, which is essentially taking a reference to an object and then assigning its value to the new object, as you can see. Okay, and then we have our destructor, which simply assigns 0 to both double number and long number. Then we have reset, which is going to reset it to 0 long and 0.0. Okay, and then there's this character string long, which essentially what it does is it will actually take the long number and it will print it inside the buffer and return that buffer, which we have already defined inside the class. Then you have the string double, which will essentially it's similar to C string long, but it is for the double, so that it can actually take the long float and put it inside the buffer and return that buffer. Here is our add version. So whenever you have an object of which you will actually call this add function. So for example, you have agnum.add, and essentially you pass it another object over here. So it is going to take that the values in underscore long number of this object and add it to the object from which it is getting called from. Okay, I hope that makes sense. And then essentially it returns a reference to the object. Similarly, I have the subtract version, which does the same thing, but we have a minus equal to over here, and then again it returns a reference. And here we have the division operator, which is going to do the same thing. Then we have the multiplication, which essentially does the same thing, and it multiplies the two numbers. And then we have the operator equal to, which is our assignment operator. Essentially what it does is it will take the values of the object which are being passed over here and assign it to the object from which it is getting called from. Okay, and this is another version. And for example, if I want to just pass a long number, I can do that, and it will assign the integer version to the long number and the double version to the double number, and again return a reference to that object. Okay, so here is plus equal to, and essentially what this one does is it will take a reference to the object. Okay, and then it is going to call add n. So this is it is going to call our add function over here, this one. Okay, which is essentially takes the number on the right hand side and adds it to the object that it is getting called from. Okay, so we call it by using this arrow add, because this is the address of our object from which we have called this plus equal to function. Okay, which is essentially on the left hand side of it, and from this pointer we are actually calling the add function, to which we are passing this second object n. Okay, so similarly we do it for minus equal to, where we do the subtraction between the values of those two objects. Here we do the division for the values of the two objects, and we do the multiplication for those two objects. Then we have the double equal to operator. Essentially what this does is it will compare the values of both the objects, right? So for example, it will take the right hand side, okay, and the reference object, it will actually compare the value of the reference object with the right hand side, which is this RHS object, and see if it is equal, and check if the second number, which is double num, is equal to the second value. And if this is true, it is going to return a true value, else it is going to return a false value. Okay, similarly we have not equal to, which does the same thing, and then we have greater than, less than, greater than, equal to, less than or equal to. Okay. Then we have the plus plus operator, and essentially what it does is it will take the object and increment the value by 1 for that object for both these variables over here, and return a pointer to the same object. Okay, and this is another version of the same thing, and essentially it calls this version internally, so you can see it is calling plus plus and passing it the object to this specific function, and then once it receives, it will again increment the number by 1 for both the variables, and then return the object by value. Okay, and similarly we have a minus minus version, and then we have these integers, long and double functions, and essentially what they do is they simply return the long number or the double number based on which function is getting called. Okay, and here you have the non-member functions that you saw in the header file. And in the non-member functions, as you can see, I'm overloading the plus operator. So what it will do is it will take the left hand side, okay, and it will assign it to a new variable over here, and then internally we call our public function, our public plus equal to operator, the over here, this one, and this one is getting called from so it gets called from here. Okay, and then we add both of these, so it essentially adds those two numbers, which is the long number and the double number, and then returns the new object over here. Similarly, we have the minus, division, and multiplication. Okay, so this is one of the number library that has been constructed for, so it is really specific to this application. And let me go to another one now this webkit.h. so this is still under development. I'm still I need to add a lot of functionality, but here's how the header file looks like. So as you can see, so obviously these are all our inclusions, and okay, so I just took a quick break, and so yes, the header file which I was showing earlier, so we have webkit.h, and so this particular class of interfaces essentially used for basically connecting to our web server and getting the information that we need by using the receive function. Okay, so I've defined a couple functions over here. These are just declared over here. They are not really defined at this point. As you can see, you have these zigzag lines which indicate that the functions are not yet defined, but they are declared over here. Okay, and so I wanted to make sure that these interfaces can run both on Linux as well as Windows. So as you can see on the top, if the MSC version is defined, that means it's a Windows socket, and then we define the respective hash. If not defines, then define this, and then include these files over here which are related to Windows. So we have windows.h, then socket2.h, then ws2 tcp/ip.h. Okay, and if it is going to be running on a Unix, which is a POSIX based system, in that case we have these files which include unistd system/time socket.h, types.h, and net database arpa inet.h. So this is the family of sockets that we are using. Okay, so these are some high level or the global variables which have been defined over here. So this is a UA string, and then there is a timeout integer variable which is defined, and then the max buffer size, the port number which is 80 for HTTP, and then we have AGWG for failure, which is in case of failure we have this -1. Okay, and now this is our class over here. Now this is actually a complete WebKit interface, and what it will do is it will connect to the target system, and it will get all the information. So like I spoke about the application earlier, right? So for example, if I'm connecting to a weather website, what I want to do here is I want to fetch the information which might include the gust of the wind, or the air pressure, or temperature, all those values. Okay, so I want to fetch that information, and the way to do that is I create this interface which has this line feed which has /r/m, which is typically an HTTP. It is a part of your HTTP request, new line character over there. Then the host is a string, and AGNum is a port. So as you saw earlier, I had defined this AGNum class, and this is the port, which is our object created from this specific class. And then I have the status code, which is again a number class, and then I have the string header and the body and the buffer. Then I have the inet6 address over here, which is the IPv6 address. This is the address length, so I'm just allocating a static array, a character array over here. Then defining error number to 0, and error string to null pointer. Again, this is for specific to Microsoft. So if it is going to be compiled in Microsoft, in that case this will be active, this section, and we will use the word class, which is used for the versioning of it, and then WS data structure. Okay, and then if so here our so this is this hash if def ends over here, and then these variables will work both in Unix as well as Windows. So here is the socket, which is a file descriptor, and it is set to 0 in this case, and then I have a socket which is set to false. Okay, and now these are our constructors. So as you can see, so essentially what I'm doing is we are still in the public access specifier. No, not really public, it is private, in the private section of our class. So I'm basically going to block all three of these constructors. So I won't have any copy constructor. So as you can see, it is defined in my private access specifier, and then the operator equal to, so that is, there is not going to be any assignment operator, and there is not going to be any default constructor. Okay, and then we have the socket close function, set error function, reset error, and HTTP status code. Then this is our socket address, SA, which is actually a pointer to the structure over there, and it returns an internet address. Okay, and then this is set blocking or non-blocking. So we can actually set the connection to blocking or non-blocking. So this is a boolean value which is set to true or false, and based on this we will use the FCNTL flags to set our connection to blocking or non-blocking. Okay, and then connect is the function which actually connects to the web server. Send is used for sending the message. So again, this is a wrapper function, as you can see, and it kind of hides everything from the user. So application programmers do not have to worry about writing the underlying complexities of connecting to a web server. They just have to write their message and send it to the web server. And then we have the receive function, which is going to receive the response from our web server. Okay, and now these are our public APIs, as you can see. So this is our constructor, which will be called with only a host. Sorry. And then we have the second constructor, which will actually take a host as well as a port number, and it initializes the host and the port, which are defined in the class while instantiating an object, and it calls a connect to it. Okay, which will use the host and the port number to connect to the destination system. Then we have the destructor, and reset is essentially used for clearing the values. Okay, and then the get error number function, which essentially returns the error number. So we have defined the error number over here. So it will return the error number, that is set, and get error string, which is again our error string over here, and get address, which is the INET address. Okay, it can be an IPv4, IPv6, any of the addresses. And then we have the status code. Okay, and then you have the string, the host API, and the port API, and these are still to be implemented, so I'm just writing it down. These will be changing in future, obviously. So yeah, this is kind of my list at this point, and here is the CPP file which I'm working on, and it is yet to be completed, but I will show you some of the basic things which I've done. So for example, this is my constructor, which takes the host, the string, and the port number, and then calls connect on it. Okay, and then this is my destructor, and then this will actually reset my value. So you can see the reset function has been implemented over here, which essentially clears the string, okay, and resets the port, which is an AG number port, which I have defined in an earlier class. And then I check if there is a socket. If that is true, then the socket will be closed, and have socket is set to false because there is no socket anymore, and the socket file descriptor is set to 0 over here. Okay, and this is used for setting the error. So again, this is specific to Windows, and if Windows is defined, if this application is going to run on Windows, in that case, this set error function will be called, which actually calls WSA get last error internally and sets the error number value. And this is another error string which was defined in the header file, as Windows requires a buffer to be set in the for the error. That's why we have the underscore error string. Okay, and the underscore error string, which is another so let me quickly show that to you. So here we have the Windows version and underscore error string, okay, which is a buffer, and then there's this underscore error string, which is the second one to capture the errors. Okay, so that is what this is. It's just setting the errors, and if we are running on a Linux machine or a POSIX system or a Unix system basically, so you have set error function, which essentially it will set the error number and call str error on the error number to get the error string out of it. Okay, and this is yet to be defined. I am still working on this. It's work in progress. Let me take you to the so this is another analytics CPP file which I've been working on, and essentially it does. So for this specific application, what I've done is I've downloaded SQLite 3, and essentially what will happen is I will fetch the data from the web server and store it on my database. So it's kind of caching, so that I don't have to query the web server again and again for the same data. Okay, so this is what it does. So here you can see there is this SQLite 3 queries which are being constructed, and these are sent to the backend. So let me quickly walk you through the header file of this. This is my analytics header file, and so here you can see, for example, I have the same Windows version. Then I will include this msposix.h, and these are some of the constants which I am declaring. Again, this information is going to be fetched from the web server, which will have the air temperature. So you can imagine 3 columns on the website where you have air temperature, the bar pressure, and the wind speed. Okay, so for example this is the website lpo.dt.navy.mil/data/dm, which will have that data that I need to fetch. Then here I'm creating a map of these variables over here, key value pairs, as you can see. Okay, and then I'm creating these tables. So the name of my SQL table is going to be analytics, and here I am actually creating those queries. So this is the create table query, which will actually create a table with the name analytics, and it is going to use ID, which is the primary key for the table, and then it will have another column which will be called as type. Okay, and then another column which is stamp, which is text, and this cannot be null, and then we have the value, which is integer. Okay, and then I define a unique index, which is a unique index, and basically turn on the timestamp on analytics. So it's kind of a unique index which is used on these two variables over here. And this is the so I'm once I get the information, I'm going to create a JSON format response which can be displayed on my page. So here you can see the JSON format, which kind of this is just the printf or the variables which will be print. So there will be values which will be printed over here in these places, and it will show me the mean. So it will actually calculate the statistics based on the value fetched from the website, and we will calculate the mean and the median. I hope you're familiar with what is a mean and a median. And then similarly for barometric pressure, we will calculate the mean and the median, and similarly for wind speed, we calculate the mean and the median. And this is not really a calculation, but it is more of the printf. The calculation will be done somewhere else. And then this is the JSON pair format which I have to use. This is going to be my host to which I am going to connect to fetch the data. Okay, and this is the URI base. So on this specific server, I want to go to this specific location and fetch that data. Okay, and this is my class, as you can see. So this is the class over here which has the database, and again this is another class which I have defined, which is called as AGDB. So that is my database class over there, and this is the analytics name. So as you saw earlier, so we have the analytics name as analytics, which is the name of our table. Okay, and then we have the structure, which is a part of our class, which has the I value, D value, which is so you saw in the AG number class we had the long and the double. So this is where the information is going to be stored. Okay, this is where the calculations are going to be stored. Then this is my default constructor. So obviously since it is in my private section, this is not going to be called, and I don't want anyone to call this. This is my webget function, which I am yet to complete, but essentially it will take a date and the type and the path, and it will actually fetch data from the server. Okay, and these are my public functions and public variables. So for example, this is a type definition, and I'm done. So my structure has been defined to analytics result over here, and then I have the static constant. So this simply returns the version number of this analytics interface. And then again this is my setter, and these are my getters. So this is used for setting the analytics database, and this is used for getting the analytics database. And then this is add line, which is essentially it will, if I don't find so let me put it this way, if I don't find the information in my database, then I'll fetch the information by using webget. Okay, and once I get the information, I will add a line to my database. Okay, and then I have the analytic result, which is going to get the mean of it, and then the median, and JSON and JSON pair. So these are yet to be implemented at this point. Then I have the let me show you some of the functions which are implemented for AG Analytics. So I was working on this, and essentially the first one is obviously the constructor that we have, and it checks if the table exists by calling this function, and then if it doesn't, in that case we are going to create that table with the name analytics underscore SQL, which is stored over here somewhere. Yeah, so this is going to be our query which will be fired, right? So here is the query which will be fired, and this will actually create those tables, right? And then we have the fetch version, which is going to, now this is a local query to my database, and I want to see if I already have the information. If I do have the information, I don't want to go and get it from the web server, and that's what fetch does. It will query my local database with that specific date value, and it will get me all the rows. Okay, so count star from that specific table where type is equal to question. So this is going to be replaced internally, and even this question mark is going to be replaced. Okay, and it is replaced over here by the type and the date. So essentially the type value goes over here and the date value goes over here. Okay, so these are the queries which I'm firing, and again these are the SQLite. So let me show that to you, the SQLite queries as well. So this is my AGDB wrapper. So this is a database wrapper which I've defined in AGDB, and essentially it is going to query with these specific queries that you see over here and get the result. And if I don't have those values in my database, then I call webget with the date next and type and path string. Okay, let me go to AGDB over here, and let me see if I have the header file. Okay, I do have the header file. Right, so this is my AGDB interface, as you can see, and this is defined as 1.0 version. And again I have the row pointer which is set to a null pointer over here, and then I'm using a map over here which is two strings, that it will be using two strings in this case. And then the file name, which is actually going to be my database file name, and then SQLite tree. This is actually a structure which is provided by the SQLite tree. So as you can see, if I just keep my mouse on it, you can see this is a database connection handle, and it's actually a .c implementation of SQLite tree. Okay. And then I'm defining a database handle. So I forgot to show you how to include this in your directory. So essentially you will have to download the SQLite 3 on your machine and put it in the folder where you have these files, and then include the header file in your the interface file that you are defining. Okay, and these are the statement handles that you see, and then we have a lot of different variables which are defined. So here obviously I'm blocking again. I don't want to expose the copy constructor, the assignment constructor, and the default constructor. So I have blocked all of these, and then I have these setters and getter methods over here that you see, which are actually productive variables. And then I have the public interface, which is defined over here. So you have different APIs, and these are yet to be defined at this point. I have just added it right now based on what I feel will be needed in this application. and this will change eventually. Okay, so this is my entire interface file, and let me show you some of the implementation over here. So for example, this is my constructor, which actually opens the SQLite database, and essentially we pass it the file name, and then there is the ropen, which will take the file name and return the database handle. Okay, and we are setting the SQLite. So we are checking if the written value is okay, and based on that we set the value to true, so that we can access the database later based on this value. Then this is used for closing the database, and here we have the clear value, which will essentially go and clear the value. Since it's a string, it will empty that particular value in our class. And then we have clear row, which is used for deleting a row, and then get query value. So this will actually query. So the select queries that you saw earlier will be passed over here, and then so this is the API which is provided by SQLite 3 header file, and essentially I'm passing the database handle, and the query null terminated string, and checking if the response is fine or not. So I'm sending a query to my database over here, and then this is another function which is going to clear the value. Okay, this is yet to be defined, so I'm still working on this. It takes so this is another version of get query value, but it takes 3 variables, not 3, actually 2 variables over here, as you can see. So one is the string reference, and the second one is a vector. Okay, so this is kind of what I have at this point, and this is my main file, and it is still under construction. As you can see, it's yet to be completed, and once it is complete, we will be able to do a lot of so we would be able to fetch information and store it on the database, and retrieve it from the database, and even create a JSON format of those strings. Okay, so I think I've pretty much covered all of these files over here. Web connection, so this is another class which I've defined, and it is yet to be completed. Okay, so once this is completed, I will create another video which will actually help you guys to understand exactly how this application works. So I hope this gives you a background in terms of what I'm trying to do, and so as soon as I know this is not really complete, and it kind of just it's just a walk through the code which I have at this particular point, but once I have a completed application, it will kind of help you understand how exactly it works. Alright, okay, so thank you so much for watching this, and I look forward to seeing you again. Thank you so much. Have a good one.